This is part 284C3m1b7c8e13b. Line 22f1fa19c3m1b7c8e13b. Symmetric spin hydrogen isotopes UFO 5G Wow Seti. Here's the alien radio signal. This video continues with the keyword research for hydrogen power ideas for a UFO engine. December 7, 2012. Today's December 31st. The keywords to research from the data from the previous video is line 22f1fa19c3m1b7c8e13, quantum transport, nanodevices, UFO 5G Wow Seti. That particular video has been broken down into about 17 videos because there were so many keywords that came up in it, okay? So the next 17 videos are going to be about the keywords and formulas from that one video. The keyword is symmetric spin state. The quotes and diagrams are from blogs. Here's a diagram here to look at. This is the case of protons and tritons. The symmetric nuclear spin states must be, and that's from hydropole.ch. Okay. Here's a schematic representation of hydrogen or protium H, deuterium, and tritium T. Tab, atomic data of hydrogen isotopes. The atomic radius of the free hydrogen atom in the ground state. The Bohr radius is that, and the covalent atomic radius of hydrogen in crystal structures is between 30 and 35 pm. The hydrogen molecule, the isotopes Hg and T form diatomic molecules. The interaction potential energy of two hydrogen atoms goes through a minimum at a certain interatomic distance. When two electrons form a singlet state, 1sg, namely the state with a total electron spin equal to 0, the combination of two electrons with opposite spin. The energy of the triplet state, 3su plus having a total electron spin of unity, increases when two hydrogen atoms with parallel spin approach each other. Hydrogen atoms of opposite spin exist in equal numbers and readily combine in pairs to form singlet state molecules. The formation of molecules can be suppressed by applying a strong magnetic field to an atomic hydrogen gas. Okay, you want to remember that. So we got triple state, singlet state. The singlet state exhibits a minimum of, in the interaction, potential energy for a proton-proton separation of that. The binding energy is this for each hydrogen atom to separate the HH bond. HH bonds and ligands come up earlier in line 22. Okay, so you're probably going to have to do some cross-referencing with that too. Quantum mechanics requires that the wave function of a molecule must be antisymmetric with respect to the interchange of the space coordinates of two fermions. Spin equals half, and symmetric for the interchange of bosons. Spin equals 1. Thus, the wave function of an H2T2 molecule should be antisymmetric on interchange of two protons, tritons, and that D2 symmetric on interchange of two deuterons. There are a total of 21 plus 1, 2 combinations of nuclear spin states for two identical nuclei of spin 1, which two spin L or I, I'm not sure what it is, okay? States are symmetric, and there's the thing, are antisymmetric with respect to the interchange of nuclei. Consequently, there are two kinds of hydrogen molecules in the singlet state, namely ortho-hydrogen, symmetric with parallel nuclear spins, and para-hydrogen, antisymmetric with antiparallel nuclear spins. When the nuclei are fermions, as in the case of protons, tritons, the symmetric nuclear spin states must be coupled with the antisymmetric rotational states, odd J, and the antisymmetric nuclear spin states must be coupled with the symmetric rotational states, even J. So figure is energy and wave functions of rotational states, J of a para-hydrogen and an ortho-hydrogen molecule. The total nuclear spin, I don't know if it's I or L, is 0 or 1 respectively, and the rotational quantum number is 0, 1, 2 to 7. The population ratio of ortho-hydrogen to para-hydrogen in thermal equilibrium is given by, there's your equations here. So these math equations will be used with the spaceship, okay? So hydropole.ch is the website to look at. December 27th, the keyword Wigner molecule is going to be in the next video. Thanks for watching.